Welcome to Homework Lib.
Hello students, in this question the main objective is to find the mass of milk. So for that first we need to find the amount of heat released by the steam as it cools down from 153 degree Celsius to 100 degree Celsius. That is the boiling point of water. So for this we'll use the specific heat capacity of steam, that is cm steam value is given in the question. So we have the formula Q1 is equal to N into cm steam into delta T, where N is the number of moles of steam and delta T is the change in temperature. Now plugging the values in this equation, we have Q1 equals, so before that first we need to find the moles of steam, that is N. We want the value of N. So number of moles of steam is given by the formula N equal to M steam by M water, where M steam value is 20 gram and M water, this is the molar mass of water. So which is equal to 18.015 gram per mole. So now plugging the values, we have N equals 20 gram divided by 18.015 gram per mole. So N equals 1.110 moles. Now we can calculate Q1. So Q1 equals 1.110 moles N into cm steam. So cm steam value given is 33.1 joule per mole Kelvin into delta T. Delta T is 153 degree Celsius minus 100 degree Celsius. So on solving, we get Q1 as 1939.3 joules. Next we need to find the amount of heat released by the steam as it condenses from steam to water at 100 degrees Celsius. For this we'll use the enthalpy of vaporization, that is delta H vaporization. So formula is Q2 equals N into delta H vaporization. So plugging the values, we have Q2 equals N value, we got 1.110 mole, that is number of moles of steam, into delta H vaporization value is given 40.67 kilojoule per mole. So on solving we get Q2 equals 45.144 kilojoule, which is equal to 45144, that is 45,144 joules. So we got Q2. Similarly, we have to find the amount of heat released by the water which was steam before as it cools down from 100 degree to 70 degree Celsius. For this we'll use the specific heat capacity of water, cm water value given in the question. So the formula is Q3 equals N into cm of water into delta T. Now plugging the values here, we have Q3 equals 1.110 moles into 75.2 joule per mole Kelvin into 100 degrees Celsius minus 70 degrees Celsius. So on solving, we get Q3 equals 2499.8 joules. So we got Q1, Q2, Q3. Now we have to find the Q total, that is the total heat released by the steam is the sum of the heat released in the three steps above. Q total equals Q1 plus Q2 plus Q3, which is equal to 1939.3 joules plus 45,144 joules plus 2499.8 joules. So Q total equals 49,583.1 joules. So we got Q total. Now we can calculate the mass of the milk. The amount of milk that can be heated from 4 degrees Celsius to 70 degrees Celsius using total heat released by the steam. Here we'll use the specific heat capacity cm water for the calculation, assuming that milk is 100% water. So we have the formula Q total equals m milk into cm water into delta T. We need mass of milk. So m milk equals Q total divided by cm water into delta T. Now substituting the values here, that is mass of the milk equals 49,583.1 joule divided by cm water value is 75.2 joule per mole Kelvin into delta T is 70 degrees Celsius minus 4 degrees Celsius. On solving, we get mass of the milk as 9.9 liters, since the mass of liquids are expressed in terms of liters or milliliters. This is the final answer. Hope you find the solution useful. Thank you.